So hello everyone, today we will have session on 5G small cell and integrated access and backhaul IAB. So let us first discuss about need for small cell in 5G. So you may be aware that the macro BTSs, the macro cells may not cover all the area and they may leave patches of uncovered shadow areas. So behind a high-rise building or any other obstacle, so there will be patches of uncovered shadow area which a macro BTS may not be able to cover, and then there will be a coverage gap inside a basement or indoor. So that is also a problem. A macro BTS may not be able to cover that. And one of the requirement of ultra high speed in 5G as per the ITU requirement and the ultra capacity requirement that within a given area large number of data rate would be required like stadium. So these are need for a small cell. These aspects requires that a small cell with higher bandwidth is deployed. Now let us talk about the relation between millimeter wave and small cell. So all of us know that 5G supports millimeter wave. So millimeter wave is higher frequencies in 28 gigahertz, 39 gigahertz, 40 gigahertz and so on. So 3GPP has actually identified millimeter wave as part of FR2 frequency range 2 during release 15, and that can be used for deploying a cell using the millimeter wave. The other aspect of millimeter wave is that it is available in abundance in most countries. So the frequency or the spectrum in FR1 frequency range 1, which is up to 7 gigahertz, are already being used by other mobile technologies like 2G, 3G, 4G and so on. So availability of spectrum is there on the millimeter wave side, which can be used. And onto the millimeter side, since spectrum availability is more, so higher bandwidth can be deployed in a cell. The 5G supports a bandwidth up to 400 megahertz compared to 20 megahertz in 4G. So a very high bandwidth can be utilized if the spectrum is available in the millimeter wave. So the millimeter wave coupled with higher bandwidth of that will support ultra high speed, that will enable ultra high speed, and the capacity support will also be high, so it will support a bigger capacity compared to the spectrum in FR1 frequency range 1 below 7 gigahertz, where the bandwidth availability will be less and hence it will not support very high speed or bigger capacity. So but one of the issue of small cell millimeter wave is that it attenuates very faster. So higher the spectrum, more the attenuation. Millimeter wave frequencies are on higher side, so attenuation will be more. So hence the coverage of a cell using millimeter wave will be very less, 10 meter, 20 meter, 50 meter and so on. So it is useful to create a small cell using millimeter wave. So for deployment of small cell, millimeter wave will be used. So within a small cell of 10 meter, 20 meter, you will have a very large capacity of the data, and also you can offer very high ultra speed. But all these will require a very high capacity backhaul. So that is a challenge, that since density of the 5G small cell deployment will be very high because its coverage is very limited. So at every place you require a high capacity backhaul. So that's a challenge. So let us discuss what are different challenges of the backhaul. So all of us are aware that the 5G new radio site will require backhaul in multi gigabit per second, and this is more so in case of a small cell using the millimeter wave because their capacity to handle data is high, so backhaul requirement would be proportional to that. So one of the choice for backhaul is a fiber connectivity. So but the problem with fiber is that the fiber connectivity is costly, and the other issue with the fiber may be that fiber may not be reaching to all the sites because sites would be inaccessible. You cannot dig and lay a fiber, so fiber cannot reach everywhere. That's the second problem. The other option is of microwave, which is generally used for deployment of sites in uh, urban, semi-urban and rural areas. So in case of a small cell, since it has to support a very high speed busty traffic, so the point to point microwave may not be suitable, may not give that much backhaul which is required by 5G. If point to point microwave cannot serve our purpose, so definitely point to multi point microwave will also be not be useful because of the limited data rate, because point to multi point means the backhaul of a point being used from the multi-point will be limited by the data rate. And even if we are able to use microwave to some extent, and if the microwave is using a licensed spectrum, so that means there is a requirement of spectrum for a microwave backhaul, and the spectrum will come with a cost because you have to buy the spectrum from the government or from a regulator in a particular country, as the case may be. So it will add to some cost, some additional cost. So these are various challenges of backhaul. So let us talk about solution. What is the solution? So one of the solution is Integrated Access and Backhaul, IAB. So let's have a look. So as part of release 16, 3GPP has introduced a new type of wireless backhaul, which is known as Integrated Access and Backhaul. So it is integrated with the new radio. So it is popularly known as 5G self backhaul. So this is a very new kind of wireless backhaul, which is 5G self backhaul. That means the same infrastructure of new radio will provide access, that is connectivity to user equipment, and also backhaul traffic it can handle. So this is just a broad example of IAB, Integrated Access and Backhaul, wherein one of the site is connected on fiber and it is providing access for various mobile phone and other devices. In addition, it is also serving as a backhaul to other sites like this. So other sites are on the same radio or the same uh, new radio, so it is able to use it for backhaul as well as for access. So your coverage from this area has increased to this area without need of separate backhaul. So this is the kind of one of the use case of IAB, that if I'm not able to take fiber to all the sites, because of cost or any other reason, I can always use the self backhaul. And since the sites are using millimeter wave where bandwidth is very large, and the same bandwidth cannot be fully utilized within this area, so I'm extending the coverage and utilizing the available spectrum in one side to other side. So basically it's a extension of the coverage and capacity. So what are the different advantages and what are the issues of IAB? So one of the advantages is it is integrated. So when we say integrated, means it is part of the same new radio. This is not a separate deployment, it is part of the same new radio components. And since it is integrated, the deployment can be automated. So if you use a separate backhaul of fiber or microwave, and there are large number of small cells, very dense 5G small cell network, so it will be very challenging to manage. Because IAB is integrated, it is possible to automate the deployment and operation and maintenance, etc. And since it is part of the NR component, so deployment can be faster. So I'm not required to wait for backhaul to reach because it is part of the same NR component, and it can be deployed either in a tree topology or as a star topology. So that means there can be a multi-hop one after another, or it can be a star topology, one donor is serving to multiple nodes, multiple IAB nodes. So both the tree topology or star topology is supported in the specification. So it is useful for a temporary 5G deployment. So I can deploy a 5G new radio temporarily to some locations. So that is one of the advantages. Then I can migrate to fiber whenever it becomes available. So today I am having backhaul using the IAB. Tomorrow if fiber reaches that particular site, I can easily migrate onto the fiber. So this is the advantage. And then there are two disadvantages, or whatever name you can call. One is that the capacity is getting shared. So basically capacity of one G node B is getting extended through various nodes using multi-hop or star topology. So it is in fact the single G node B and various components, in particular the DU, is getting extended as a node. So the capacity, same capacity is getting shared in all the nodes. And the other aspect is if you have multiple hops, so your latency may also get impacted. Latency impact will also come on the scheduling aspect, because so in a TDD environment you schedule uplink traffic and downlink traffic for users. Now you also have a backhaul traffic which is to be scheduled within the same structure, so there will be impact on latency because of that. So the capacity would be shared, so that's a limitation coming, and the latency will also impact. So these are two issues, and so advantages are much higher compared to the disadvantages, all because capacity sharing will not be an issue because of the higher bandwidth. You already have a capacity which you can extend, and latency also, if you use number of hops, if you can limit, so latency impact will be minimized. So you cannot just deploy 10 hops or 15 hops. That may not be a good solution, but 2-3 hops 2 hops or 3 hops will be okay, and latency having will be not impacted much. So depending upon the use case and the latency requirement, perhaps one can think of having a IAB backhaul or having a dedicated fiber or microwave backhaul. Now let us look at 3GPP specification for IAB. So 3GPP in its specification 38.401, so that is a specification for NG-RAN architecture. So in this document they have also given architecture of IAB, and in IAB there is a new protocol which has been defined called BAP, which is Backhaul Adoption Protocol. So it is technical specification 38.340, where this BAP protocol is actually given. So we will talk about that protocol a little bit. So if you want to actually read in detail, you can download these two documents and read these two 3GPP specifications, in particular the IAB part in it. So this is a basic architecture of IAB. So as I said that it could be a star topology or it could be a tree topology. So the architecture is said to be scalable. So when I say scalable architecture of IAB, what we mean that I can have any number of hops connected in either tree fashion or mesh fashion, or any way you can do it. So there is no limit. If you read the specification has not given any limit in number of hops. How many hops I can have is not limited in the specification. Then can I have unlimited number of hops? Answer is no. Why? All because it will be limited by the network performance. And when we say network performance, I talked about capacity sharing, and the second is the latency. These are the two important network performance parameter which will have impact on number of hops being used in IAB. And the IAB, the backhaul which we get using the IAB gives a generic IP connectivity. So generic IP connectivity is available. It becomes available. So it will carry the traffic which is required for IAB, connecting those nodes, and it can also carry any other traffic which may be required, being a generic IP connectivity. And whenever a site becomes feasible for a fiber, then you can easily upgrade to fiber because it is a generic IP connectivity, so replacement with fiber would be easy. So this is the basic architecture of the IAB. This image is taken from Qualcomm. So now let us look at 5G new radio architecture and how it is enabling IAB. So if you go through the 3GPP specification architecture document and the document related to protocol, so the G node B, which is the RAN, radio access network, or new radio NR, uh, actually supports all these protocols. So RF, physical layer, MAC layer, RLC layer, VDCP, RRC, and SDAP for QoS. So G node B, if it is a single product or a single box product, then it handles all these protocols, and U gets connected and it is connected to 5G on the other side. But the 3GPP specification has given an option that this G node B can be split into two products called CU and D. CU is central unit and DU is distributed unit. So some part of these protocols are handled at DU and higher level protocols are handled at CU. So in particular in 3GPP specification, this much physical MAC RLC. So this much is handled at DU and rest of the protocols are handled here. This is also known as split 7. So 3GPP has also given a study document wherein they have tried to give various options of split between these protocols and try to create from a single product version of G node B to a multi product G node B, CU, DU, etc. So now let's go slightly detail. So now if you look at G node B, as we discussed there, that the G node B can be a single product or G node B can be divided into two products, CU, which is central unit, or and DU, which is the distributed unit. So basically the G node B is getting disaggregated into G node B CU and G node B DU, and they are connected on a open interface which is F1 defined by 3GPP, and one CU, G node B CU, can connect multiple DU unit. Now if you look at the central unit, this is further divided into two parts. So G node B central unit, the control plane part, which handles the control signalings, and G node B central unit user plane parts, which handles the user plane part of it. So here also a control plane CU can connect to multiple user plane CU on E1 interface. So it is again, so the CU can further be disaggregated into multiple product CP and UP, and these distributed units can get connected. The user plane part gets connected here and control plane part is connected on F1 interface. So the G node B CU is disaggregated into G node B CU CP and G node B CU UP. So this split architecture is used for IAB implementation. Integrated Access and Backhaul uses the split architecture. So you cannot have a single product G node B and use IAB. To use IAB, you need to have the split architecture, and then and this also enables efficient multi-hop support. So let us look at that. So how it looks like when G node B is using the IAB concept. So here the nomenclature becomes IAB donor CU. This is control central unit, so it becomes a donor CU and it is in donor DU. So basically one CU and one DU becomes the IAB donor, and with this now you have IAB node 1, IAB node 2 connected in a hop, and the interface is again F1. So these F1 interface are, these two F1 interface are actually being going on IAB, that is Integrated Access Backhaul, on the F1 interface to IAB donor CU, whereas the co-located DU with CU uses a wired connection and they are also have an F1 interface. So basically the all IAB nodes, these nodes, these nodes, these nodes, and the donor one uses the same CU of the G node B. So that means the IAB, the wireless backhaul, is implemented within one G node B. So that means it is isolated. It is internal to the G node B. So it will not have any impact on the 5G. And for UEs, so all those user equipment being served by these IAB nodes or donor DU, they will also not see any difference. For them, it appears as a normal base stations. For these UE being served by different IAB nodes will appear as a normal base station, so they will not be impacted. And the architecture supports SA and NSA deployment. So in case of a standalone deployment where you have 5G core and G node B, this can be used. In case you have a NSA mode of deployment where core is 4G and you are using 5G uh, radio as part of the 4G network itself, wherein the 4G LTE base station E node B becomes a master E node B, ME and B, and 5G nodes are connected through that. So there also this IAB concept can be used. Now let us look at various use cases of the IAB, in what all scenario IAB can be used. So the first use is extending the coverage inside an indoor environment. So inside an indoor environment also you can put a IAB node very small in size, and then you can extend the coverage in an indoor environment. So it can be used in factories, it can be used in normal houses, it can be used in multi-story building, halls, offices, etc. The second use case is suburban. So in case of a suburban environment where you don't have much high-rise building, so one cell can be a donor cell and other cell can be an IAB node, and you can extend the coverage, provide the coverage in the suburban area pocket. And of course urban scenario would again be useful because you can have a street coverage using IAB nodes where you have a multi-story building. So maybe on a top of a building you have a donor cell site, and all the nearby street you are able to use IAB concept and extend the coverage onto those streets. And then the temporary deployment, in case there is some event in a stadium and you want to provide extra capacity and coverage, then you can put an IAB temporary node there and it will kind of provide the required capacity and coverage. So these are various use cases of IAB, and there will be a lot of innovation of these use cases. So let us have a look at pictorially that how the use cases will look like. So if you look at this particular example wherein a 5G small cell is installed here and users are in this coverage area, it is say covering this much area. So the signal beyond this is weak. The spectral efficiency will also be low because even if you are able to serve a customer, you will not be able to provide him a good speed. So spectral efficiency would be poor in this area. So the solution to this is that I add one IAB node here which will use the wireless backhaul from the donor base station, and then extend the coverage. So as the capacity was already available for this particular cell site, that capacity got extended, and now you have larger coverage, utilization will increase, spectrum efficiency will increase, and so on. So this is a use case of extending the coverage. Now the second use case is again shown for extending the coverage. So here the fiber is coming to this particular node. So this becomes a donor node, and then you can using a backhaul. So earlier you were able to cover this much area using this small cell. Now with the another small cell. With IAB node, you are able to cover this area now. And if you have one more hop, so again it is going here and then you are able to cover this area additionally. So the coverage extension can be one of the use case of IAB. So and these pictures are taken from Samsung website. So here is an example where your fiber is coming up to this particular cell site. It is okay, and so it may not be able to cover this street in a better way. So a cell site is deployed here using the IAB concept, and this particular antenna is taking backhaul from this site and then extending the coverage onto this street using, and it is using the same beam forming concept, so that devices, so beam forming is done up to the devices. So this is one of the good example of street coverage using IAB. So now there can be a coverage gap. For example, if you look at this particular cell site providing access to the various user equipment, but because of this high-rise building, its coverage is limited here, and the devices or the UE this site may not be able to get signal, and this site may not be able to serve. So one of the use case of IAB is that using the wireless backhaul, you deploy another cell IAB node or the hop, and then these users can use the 5G signal or 5G services here. So filling the coverage gap is one of the use case of IAB. Now there can be coverage holes. For example, if you have IAB donor node here, so you are able to cover this much area, but because of this obstruction, the coverage on the street this side will be not there. So what they do is that they can deploy a IAB node here, which will take backhaul wirelessly from this particular IAB donor and extend the coverage in this direction. So this is another use case of covering a street where you are not able to reach, the fiber is not able to reach. The fiber is able to reach to certain location, and you can extend it using the IAB concept. So now let us look at how the backhaul signals are received and what are the terminologies used. So just look at this particular picture from Samsung. So here fiber is coming up to this particular cell. So this is a donor cell as we call it, and there are one hop, two hop. So this is called IAB node. So IAB node 1, IAB node 2. So basically even the nodes are able to provide backhaul. So in this example, what is done here is that this particular is an array of antenna to receive the backhaul signal, and this is also same for the backhaul antenna, and this antenna is for users for providing the access. So this particular antenna is providing access to user and also access to the backhaul simultaneously. We can say we will look at how scheduling happens for these two aspects. And here the same antenna is providing backhaul and also to the access to UEs. So this particular antenna is called IAB MT. IAB MT is mobile termination, and this unit is the DU. So all are DU, but the donor is kind of co-located with the CU. So this donor is nothing but a distributed unit, but it is co-located with CU. This is DU, we call it IAB DU, and this is also a DU, IAB DU. So this antenna is called IAB MT. So this can be a separate as shown in this example, or it can be part of the same antenna. right? So you can have same antenna and it can also. So when the same antenna is used, we call it virtual IAB MT. Virtual IAB mobile termination. When there is a separate antenna, we call it IAB MT. When the same antenna is used, then we call it virtual IAB MT. So these are the terminology and the uses of IAB. So this is again a picture from Samsung where they have shown that this is an IAB MT mobile termination and this is the distributed unit. So it is taking backhaul from some site and then extending the coverage this side. Now let us look at the protocol part, the backhaul adoption protocol introduced for IAB by 3GPP. So just see this particular picture. So let me explain. So this is IAB donor where CU and 1DU is co-located. This is say node 1, IAB node 1, where you have DU and also the IAB MT to receive the backhaul traffic or for backhaul traffic. And here it is a virtual IAB MT. So just look at the picture below. So here what is shown is a separate antenna for backhaul reception, and here the same antenna which is used by users are also for backhaul. So that's why if the same antennas are being used for backhaul, then we call it virtual IAB MT. I explained that, and otherwise we'll call it IAB MT if there is a separate antenna. So if you look at the protocol now, so MAC layer, RLC layer, so one WAP layer had been added onto which IP traffic flows. So basically the WAP enables efficient IP data forwarding across the IAB interconnected radio nodes. And within that, you can have multiple channels for different traffic prioritization and QoS enforcement. So the quality of service can be enforced within the WAP. And so this WAP will not only support this backhaul, which is nothing but F1 traffic, but can also support any other traffic like ONM of IAB or any other traffic, any IP traffic requirement can be handled over this WAP. This IAB backhaul is of course for F1, but it can also be used for any other purpose required for any IAB node. So this is slightly detailed protocol stack for F1 user plane. You can go through this. This is taken from the 3GPP specification document where they have talked about these physical MAC and RLC layer. On top there is a BAP layer, and then of course on top of it you have IP, UDP and GTPU. So this is called backhaul RLC channel. These are backhaul RLC channel, and this is intra donor F1. Similarly, for control F1 control plane, these protocol stack are shown. So here you have on the top you have a slightly different protocol, IP, SCTP and F1AP. So you can go through these in detail reading the specification document. Now this is very important that how the backhaul traffic or user traffic is scheduled. So we will take one example wherein we will talk about how a TDD system, time division duplex system, scheduling of uplink traffic, downlink traffic from user perspective as well as the backhaul traffic is scheduled. So let us look at this particular picture. In this example also I have the IAB donor, so wherein CU and donor DU is co-located, and then I have node 1 and node 2. This picture is taken from a paper published by Erickson. Link is given below. And this node 1 consists of a distributor unit, also an IAB empty for backhaul, and this also same DU and IAB empty. And as I explained, as far as protocol is concerned, so you have MAC RLC and the BAP layer, VAP protocol. And as I explained that the BAP protocol supports F1 required for backhauling. It can also support ONM of IAB or any other IP traffic it will support. So now let us look at this particular picture where this is a parent. The donor, IAB donor is parent. Parent terminology is in respect of the backhaul which we're talking about. This particular node 1 is a child because it will backhaul to this parent, and it is a parent for this particular next node, node 2. So node 2 is only child, so it will act as a child in this direction and parent in this direction. So now let's explain how scheduling will happen. So as I said, this is an example of TDD, time division duplexing. So the backhaul traffic is scheduled during downlink time slot. So for a user perspective, you have uplink traffic and you have downlink traffic. So whenever there is a downlink traffic time, during that time the backhaul traffic will be scheduled. So just see here that in this particular picture we have shown various phases, phase 1, phase 2, phase 3, phase 4 and phase 5, and then it will repeat. And these arrows are for backhaul traffic directions. So if it is a downstream, then direction is this. If it is upstream, direction is this. So here both direction will be there, here also both direction will be there. And the user traffic, these arrows are showing downlink and these arrows are showing uplink. So let us look at phase 1. So during the phase 1, so one aspect here is that IAB empty, your IAB empty cannot receive while the DU, the co-located DU is transmitting. So when this DU is transmitting for UE, at that point of time this IAB empty cannot receive the signal, or while it is receiving there will not be downlink traffic. Just understand. So basically if you look at various phases, so phase 1 is for downlink traffic, phase 2 is also for downlink, just see, phase 3 is also for downlink, and phase 4 is also for downlink, and phase 5 is you have uplink traffic. So that means as I said, that backhaul traffic will be scheduled during downlink time slot. So that means during phase 1, phase 2 and phase 3 we will be scheduling the backhaul. So whenever a backhaul will be scheduled and a particular node will receive a backhaul signal, at that point of time, as I explained, that when IAB empty receives backhaul signal, DU will not transmit. So in phase 1, it is expected that this particular node 1, will receive backhaul signal from node 2 as well as from the parent. So during this time, it will not do a downlink transmission for the users, which will only be receiving the backhaul transmissions, whereas the parent node and this particular child will continue to do downlink traffic because they are not receiving any backhaul traffic. So it will be scheduled in such a way that during phase 1 the parent and child can do the downlink transmission for the users, whereas the node 1 will not do downlink but it will receive the backhaul signal from both sides. Now in phase 2, this node 1 is doing downlink transmission for the users, but it is now sending backhaul parallelly. It is sending backhaul signal also towards parent and towards the node 2. And since now parent is receiving a backhaul signal, its downlink is blocked. Similarly, this node 2 is receiving the backhaul signal, so its downlink for the user is blocked. So now in phase 3, again the node 1 is receiving backhaul signal from the parent, this one. So since it is receiving some backhaul signal, its downlink will be blocked, whereas parent and node 2 downlink transmission will continue. In phase 4, all three nodes are doing the downlink transmission and there is no backhaul transmission happening. In phase 5 is fixed for uplink transmission. So this is a kind of scheduling which can be done, and it will repeat phase 1, phase 2. So it is a kind of scheduling which has been done to do a uplink transmission and downlink transmission for user equipment and also for the backhaul equipment. So these schedulings are very flexible. So it is up to the OEMs and operators to use a certain kind of scheduling, so that can be configured. This is just an example which I give you based on a paper published by Erection. So with this, I have come to end of this particular session. So let us summarize. So that means the 5G new radio supports access for users, user equipment, and also the backhaul or integrated wireless backhaul. So same equipment will provide access as well as backhaul. And the IAB can be deployed in a tree fashion or in a star fashion. Both topologies can be used. And IAB is scalable. In scalable means you can have multiple hop, but it is only limited by performance in terms of capacity and latency majorly. And then the IAB may be an backhaul option for urban deployment, suburban deployment, indoor deployment, and temporary sites, which we explained. And any IP traffic, be it F1 interface traffic or O&M of IAB traffic, etc., can be routed through this IAB. So the BAP protocol supports all kind of IP traffic onto that backhaul. And IAB is isolated within G node B. So that means it will not have any impact on 5G core. So whatever is there, it is inside G node B itself. So it will enable faster deployment and automation of deployment, because you don't have a separate backhaul to manage. So you can even automate the deployment and O&M part of it. And finally, whenever need be, it can always be migrated. IAB can always be migrated to a fiber or a microwave, as the case may be. So thank you very much. Thanks a lot.